All right, let's take a few more examples. You have to see a bunch of examples of these just to get sort of some comfort level with how to approach these. So here we go. The dimensions of the rectangle of largest area that has its base on the x-axis and its other two vertices above the x-axis and lying on the parabola y equals 8 minus x squared. So a very graphical one here. Again, I want to think, well, what are we trying to do? We're trying to maximize area. Again, I'll just call it A. I could get a picture of this because we have the parabola 8 minus x squared. All right. So that would be here at 8, and we can think of looking at this rectangle. So it's going to have its base here, and then it's saying that the other two vertices are on the parabola, so it would have to be something like this. So this is the rectangle that we're looking at. So what we want to know is when, now we have this restriction that these vertices have to be on the parabola here, so we'd be comparing that with ones that are like this, or ones that are like this, and we're trying to figure out which one of these rectangles we should use to get the most area here. So I'm just going to get rid of those other ones. Oops. There we go. Okay, so let's put some values in here. Now, we know that, because this is already set up, we know that this is basically the x here. This is of length x, and this is also length x. This has to be symmetric, and it's going to be height y. Okay, so we see that the area of that rectangle is going to be 2x, which is this, times y, or in other words, 2xy. All right. So that's what we're trying to maximize. That's our objective function. And we also know that y has to be 8 minus x squared. That's our constraint. That's how x and y are tied together here. Furthermore, we know that the smallest x would be when we're in there. Well, we don't really want an x of 0. We're not going to get a rectangle. And the biggest x would be out here, and that's when x squared is 8, or x is plus or minus the square root of 8, or in other words, plus or minus 2 square root of 2. But in this case, on that end, it would be 2 square root of 2. It would be negative 2 square root of 2 on the other end, but you get the whole symmetric problem. Okay, so we know the domain here is actually 0 to square root of 2. We can't really have either one of them because then we're not going to get a rectangle anymore, but anywhere in between. All right, so as usual, we're going to take what we had for our area, 2xy, and substitute in the constraint so that we get a only as a function of x, getting 16x minus 2x cubed with a domain of 0 to square root of 2. So our problem has become maximize, and we are trying to maximize here. A of x is 16x minus 2x cubed on 0 to square root of 2. All right, so let's see. Okay, all we need is a derivative. 16 minus 6x squared. I'm going to set that equal to 0 and see where it's undefined. It's not undefined anywhere. Set it equal to 0, and I get 16 minus 6x squared is 0. I get 6x squared is 16, or x squared is 8 over 3. This is not going to give me a very nice. X is plus or minus square root of 8 over 3, or in other words, plus or minus 2 times the square root of 2/3. Okay, so not a pretty number, but we'll deal with it. Okay, so let's figure out where that puts us. Well, again, we're between 0 and 2 radical 2. 0, 2 radical 2. And this 2 square root of 2 is 2.8-ish. And this 2 radical 2/3, which we're going to take the positive one, is like 1.6-ish. So we're somewhere in there. So we'll put it 2 radical 2/3 in there. All right. And so if we go back to our derivative here, if we put, say, 1 in there, we get 16 minus 6, we get a positive. And if you put something like 2 in there, 2 is in the second region there, you'd get 16 minus 24, you get a negative. So we have our classic, this was a prime here. So if a prime is positive, then a is increasing. If a prime is negative, then a is decreasing there. So it was increasing and decreasing. That means we get a relative max here at 2 square root of 2/3. And then we'd have to plug that in. Y is 8 minus x squared. That's y equals 8 minus, well, that squared we knew was 8/3. So this is going to give us y of 16/3. So that's the y value associated with the function here. I'm sorry, that's the y value of the point. That's not actually the area you would get, but that's the going towards the dimension of the rectangle. The area, we would actually have to do this calculation right here, which is going to be a pretty terrible number, so I'm just going to leave that for now. And as I don't need to find out what the area, just where the point is that maximizes it. All right, so what I found is that that's a relative maximum there. And again, because it was increasing before and decreasing after, this has to also be my absolute max. All right, so if we go back, we see our rectangle was 2x by y, so 2 times this, so the 2x dimension would be 4 times the square root of 2/3, and y would be 16/3, and so our rectangle should be 4 square root of 2/3 by 16/3. Those are the dimensions.